Mastering the quotient rule takes practice, and today we're going to practice with these 20 quotient rule problems. In most cases, we're just given a function and we'll find the derivative, though you can see that some of the problems are a little bit different. At the end, I'll give you a few challenging bonus problems you can try to solve, and there are also chapters in the description, so you can skip around the problems as you please. Let's begin. Here is the quotient rule for our reference. The derivative of a quotient of functions f of x divided by g of x is f prime g minus g prime f all over g squared. Let's begin with problem 1. We're given that y equals 3x minus 4 divided by x squared plus 1, and we want to use the quotient rule to find y prime. Hopefully the quotient of functions here is pretty obvious. F of x we could call our numerator, which is 3x minus 4, and that's getting divided by the denominator, x squared plus 1, which we could call our g. So then to find the derivative, we apply the quotient rule, beginning with f prime times g, the derivative of the numerator times the denominator. The derivative of the numerator, f prime, is just 3. That's the derivative of that. And then we multiply it by g, the denominator, which is x squared plus 1. Then we subtract, make sure you don't miss that, it's subtraction, g prime, the derivative of the denominator, times f, the numerator. G prime, the derivative of the denominator, is 2x. And then we multiply that by the numerator, f, which is 3x minus 4. Finally, we divide by g squared, and typically we will not expand this unless there's a good reason. Just write g and square it. You could try to expand and simplify the numerator. I'm not going to do that throughout this video because I don't want to spend an hour doing algebra. I want us to just focus on applying the quotient rule. Let's move on to problem 2. Q of x equals 4 plus 1 over x divided by 3 minus x. And we will take the derivative in order to find q prime of x. Again, if you want to label things, the numerator, 4 plus 1 over x, is our f, and the denominator, 3 minus x, is our g. Then, applying the quotient rule, we begin with f prime g. F prime is the derivative of the denominator, and we can see the derivative of 4 will be 0. 1 over x is x to the negative 1, so we can take the derivative of that using the power rule. That gives us negative x to the negative 2. That's f prime, and then we multiply it by g. Then we need to subtract g prime f. G prime is actually just negative 1, and then we need to multiply that by f, which is 4 plus 1 over x. Now this negative 1 from g prime, we can just multiply it by this minus in order to turn it into a plus. And after we do that, we just need to write g squared in the denominator. G is 3 minus x, so g squared is 3 minus x squared. And that is the derivative q prime. Moving on to problem 3, we want to take the derivative of 1 minus cosine x divided by sine x. 1 minus cosine x, the numerator of course, is our f, and sine x, the denominator, is our g. So it should be pretty straightforward to apply the quotient rule here. We begin with f prime g. F prime is the derivative of the numerator. The derivative of 1 is 0. The derivative of cosine x is negative sine x, but don't forget there's a negative in front of it, so the derivative will be positive sine x. That's our f prime. Then we need to multiply it by g, which is sine x. So we'll have sine x times sine x. Let's just write that as sine squared x. Then we must subtract g prime f. G is sine x, so g prime is cosine x. And then we multiply that by f, which is 1 minus cosine x. The denominator is g squared, which is just sine squared x. On to problem 4. F of x equals 4x divided by x squared plus 1. Our objective, of course, is to find f prime of x. Now in this problem, because the function's name is f, we run into a bit of overlapping notation if we try to apply the quotient rule using the same notation we normally do. What I'm saying is that it would be awkward to call the numerator f because f is already the name of the function as a whole. In this situation, it's not a big deal. You just might want to use different letters. So a common choice is to use u and v instead of f and g. So u will be 4x, and v will be the denominator, x squared plus 1. Then the quotient rule, instead of being f prime g minus g prime f all over g squared, becomes u prime v minus v prime u all over v squared. So let's begin with u prime v. U is 4x, so u prime is 4. And then we multiply that by v, which is x squared plus 1. Then subtract v prime u. V is x squared plus 1, so v prime is 2x. And we have to multiply that by u, which is 4x. Finally, divide by v squared, which is x squared plus 1 squared. 2x times 4x is 8x squared, so I'll make that one really quick step just to make this look a little nicer. And that is our derivative. Let's move on to problem 5. We're taking the derivative of w squared plus 8 divided by 3w plus w squared. We're taking the derivative with respect to w. Now we can see, of course, the numerator, our f, is w squared plus 8. The denominator, our g, is 3w plus w squared. So we'll begin with f prime g. F prime is 2w, and then we multiply that by g, which is 3w plus w squared. Then we must subtract g prime f. G prime is going to be 3 plus 2w, and then we must multiply that by f, which is w squared plus 8. Finally, we have to divide all of this by g squared. G is 3w plus w squared, so g squared is that, but square it. You can see, of course, there is a lot of power rule going on in these problems. I'll leave links in the description to my lessons going over the power rule if you need to brush up. Problem 6 is to find the derivative of s squared divided by the square root of s minus 2. We're taking this derivative with respect to s. Of course, the numerator, s squared, is our f, and the denominator, root s minus 2, is our g. Remember that the square root of s is the same as s to the 1/2, so when we take that derivative, we'll be using the power rule. All right, so let's begin with f prime g. F is s squared, so f prime is 2s, and then we multiply that by g, which is the square root of s minus 2. Then we have to subtract g prime f. G is s to the 1/2 minus 2. The derivative of minus 2 will just be 0, so we just have to take the derivative of the root s, or the s to the 1/2, and that's 1/2 s to the negative half. That's just applying the power rule. So that's g prime, and then we multiply it by f, which is s squared. We must divide all of this by g squared, which is the square root of s minus 2 all squared. And I'll go ahead and simplify the s to the negative half times s squared. That's the same as s to the 3/2, so I'll just write it like that. And there is our derivative. Moving on to problem 7, the derivative of sine theta over theta squared. We can see, of course, that sine theta, the numerator, is our f, and theta squared, the denominator, is our g. Then, applying the quotient rule, we begin with f prime g. F prime, the derivative of sine theta, is cosine theta, and then we multiply that by g, which is theta squared. Then subtract g prime f. G is theta squared, so g prime is 2 theta, and multiply that by f, which is sine theta. Finally, divide all of this by g squared. Theta squared squared is theta to the 4th, so we'll write it like that. And there is our derivative. Just a touch of simplification, we could cancel out a theta from everything here. So theta to the 4 becomes theta cubed, theta squared becomes just theta, and 2 theta sine theta becomes 2 sine theta. That's just some quick simplification. Moving on to problem 8. g of t equals cosine of t over t cubed, and we want to find g prime of t. We'll begin with the derivative of the numerator times the denominator. The derivative of the numerator is negative sine t. Multiply by the denominator, that's t cubed. Then we must subtract the derivative of the denominator multiplied by the numerator. The derivative of the denominator is 3t squared, and we multiply by the numerator, which is cosine t. Then the denominator is g squared, so t cubed squared, which is t to the 6. Finally, we could cancel out 2 factors of t from everything, so t cubed becomes just t squared goes away completely, and t to the 6 becomes t to the 4. And that is g prime. Moving on to problem 9, f of x equals x cubed plus 3x plus 3 divided by x cubed minus 3. We want to find the derivative evaluated at 1, f prime of 1. So let's begin by just finding f prime, and then we will plug 1 into it. Now again, if we wanted to label things here with f's and g's, we would run into overlapping notation. Let's go ahead and skip the labels for now and see how it goes. First, we need the derivative of the numerator multiplied by the denominator. The derivative of the numerator is 3x squared plus 3. Then multiply by the denominator, which is x cubed minus 3. Then we need to subtract the derivative of the denominator, which is going to be 3x squared, multiplied by the numerator. This is the numerator, so that's going to be x cubed plus 3x plus 3. Then we have all of this divided by the denominator, x cubed minus 3, squared. This is f prime of x. Now we just need to evaluate this at x equals 1. Let's just plug 1 into all of these pieces. This will be 3 plus 3, which is 6. This will be 1 minus 3, which is negative 2. This will be 3 times 1, so 3. This is going to be 1 plus 3, so 7. And the denominator is going to be 1 minus 3, so negative 2, squared, which is positive 4. So we have 6 times negative 2, which is negative 12, minus 3 times 7, so minus 21, and then divide that by the denominator of 4. Negative 12 minus 21 is negative 33, so this is negative 33 over 4. Next, problem 10. This one's a little different. F of x equals x squared divided by g of x. We want to find f prime of 2, given that g of 2 equals 1 and g prime of 2 equals 0. Let's begin by just applying the quotient rule in order to find the derivative of f prime of x, and then we'll apply the given information to evaluate f prime of 2. As usual, we begin with the derivative of the numerator, so 2x, multiplied by the denominator, which is g of x. Then we have to subtract the derivative of the denominator times the numerator. The denominator we just know is g of x, so we'll have to write its derivative as g prime of x. And then we multiply that by the numerator, which is x squared. Then divide by the denominator, g of x, but square it, so g of x squared. Then we just have to plug 1 into this we have to plug 2 into this to get our answer. So what is f prime of 2? Well, in the numerator, we have 2 times x times g of x. That's 2 times 2, which is 4, times g of 2. G of 2 is given to us as 1. So this whole term is just equal to 4, because it's 2 times 2 times 1. Then we have to subtract g prime of 2 times 2 squared. G prime of 2 is 0, so this is just going to be minus 0. Then we divide by g of 2 squared. G of 2 is 1, so g of 2 squared is 1. And so we see the answer is simply 4 over 1, or 4. That is f prime of 2, evaluated using the quotient rule and the given information. Next, problem 11. Y equals 2 minus 1 over x divided by x plus 4. And we'll use the quotient rule to find y prime. The numerator, our f, is 2 minus 1 over x. Remember that 1 over x is the same as x to the negative 1, so we can take that derivative with the power rule. The denominator, x plus 4, is our g. So we begin with f prime g. F prime is just going to be x to the negative 2. When we take the derivative of 1 over x, we get negative x to the negative 2, but that negative gets canceled out by this negative. So x to the negative 2 is f prime. Multiply that by g, which is x plus 4. Then subtract g prime. G prime is just 1, so it's 1 multiplied by f, which is 2 minus 1 over x. Finally, this gets divided by g squared. And that is our derivative, though of course we don't need to write that multiplication by 1, so I'll just get rid of that. That's y prime. Next, problem 12. We're taking the derivative of x squared plus c squared divided by x squared minus c squared, and we're taking this derivative with respect to x, which means that the c's will be constant. We need to begin with the derivative of the numerator. We're taking the derivative with respect to x, so the derivative of the numerator is 2x. And then we multiply by the denominator, x squared minus c squared. Then subtract the derivative of the denominator multiplied by the numerator. The derivative of the denominator is 2x. And then multiply by the numerator, that's x squared plus c squared. Finally, divide by the denominator, x squared minus c squared squared. There is some simplification we could do. If we factored a 2x out of the numerator, this x squared would cancel out with this x squared, and this minus c squared would combine with this minus c squared to give us minus 2c squared. You can write that out if you want, but again, I'm not going to spend too much time on the algebra. Let's move on. Next, problem 13. T of x equals secant x divided by x, and we want to take the derivative to find t prime of x. Hopefully you remember the derivative of secant. It's secant tangent. So we'll begin with f prime g, the derivative of the numerator, which is secant tangent, multiplied by g, the denominator, which is x. Then we subtract g prime f. G prime is the derivative of the denominator, which is just 1, and that gets multiplied by f, the numerator. So we end up just subtracting secant x. Finally, divide by g squared, which in this case is x squared. That is our derivative t prime. Let's move on to problem 14. Problem 14 says y equals 1 plus cosecant of x divided by 1 minus cosecant of x. We want to find the derivative of y with respect to x evaluated at pi over 6. So we'll apply the quotient rule in order to find y prime, and then we'll plug in x equals pi over 6. Remember, the derivative of secant is secant tangent. The derivative of cosecant is similar. It's negative cosecant cotangent. With that in mind, we can begin finding y prime. It starts with f prime g, the derivative of the numerator times the denominator. The derivative of the numerator will just be the derivative of cosecant of x, since the derivative of 1 is 0. The derivative of cosecant x is negative cosecant cotangent, and then we have to multiply this by the denominator, which is 1 minus cosecant of x. Then we'll have to subtract g prime f. So we'll subtract the derivative of the denominator multiplied by the numerator. The derivative of the denominator will just be like the derivative of the numerator, except the negative that comes from the derivative of cosecant will cancel out with this negative that's already there. So g prime is just going to be cosecant x multiplied by cotangent x, and then we need to multiply this by f, the numerator, which is 1 plus cosecant x. Finally, we divide this by g squared, 1 minus cosecant of x squared. So we'll put that in the denominator, 1 minus cosecant x squared. That is y prime. Now we just have to evaluate this at pi over 6. Hopefully you remember your unit circle. Cosecant of pi over 6 is equal to 2, because sine of pi over 6 is 1/2. So this is 1 over 1/2, which is 2. Cotangent of pi over 6 is equal to the square root of 3. With this in mind, we can plug these pieces into y prime. We're evaluating it at pi over 6, and we'll figure out what it equals. And this is what we get after we plug all the pieces in. Cosecant of pi over 6 is 2, so 1 minus 2 gives us this -1. Similarly, 1 plus 2 gives us this 3. In the denominator, 1 minus 2 is -1, which gets squared to give us +1. This is y prime, the derivative of y, evaluated at pi over 6. Let's just finish simplifying this. The denominator of 1 doesn't do anything. On the left, we have positive 2 root 3, because the two negatives cancel out, and we subtract 6 root 3. So in total, we have -4 root 3. That's our answer. Let's go ahead and move on to problem 15. U of w equals 1 over w, and we want to find u prime of w. Now, we can use the quotient rule here, because we have 1 divided by w. The smart decision is to not use the quotient rule, however, because 1 over w is the same as w to the -1, so just use the power rule to take the derivative of this. However, we can use the quotient rule, so I'll show you how that works out. Again, this is just recreation, this is practice. I would not actually advise using the quotient rule in this situation. We begin with the derivative of the numerator times the denominator. The derivative of the numerator is 0, so nothing happens there. We have to subtract g prime f, the derivative of the denominator, times the numerator. The derivative of the denominator is 1 times the numerator is 1. So our numerator is just -1. We then divide by g squared, the denominator squared. You can see I made the fraction bar way too big. Very simple application of the quotient rule. We get -1 over w squared, which is the same as -w to the -2, which is exactly what we would have got if we applied the power rule to w to the -1. Next, problem 16, the derivative of cotangent theta. Hopefully you recall that cotangent is the reciprocal of tangent. Tangent is sine over cosine, so cotangent is cosine over sine. Thus, we can take the derivative using the quotient rule, because cotangent is a quotient of cosine and sine. Applying the quotient rule, we begin with f prime g, the derivative of the numerator multiplied by the denominator. The derivative of the numerator is negative sine theta. If we multiply that by the denominator, we end up with negative sine squared theta. Then subtract the derivative of the denominator times the numerator. The derivative of the denominator is cosine theta, multiplied by the numerator is cosine squared theta. Finally, divide by g squared, the denominator sine squared. Now you have to recognize we can apply the Pythagorean identity. We could factor a negative out of both of these terms, which would make them both positive. I can just write it like that. We pull the negative out, and now they're both positive, which means we can apply the Pythagorean identity. Sine squared plus cosine squared is 1. So the numerator is -1. The denominator is still sine squared theta, but 1 over sine is cosecant. So by definition of cosecant, this is negative cosecant squared theta. That is the derivative of cotangent, similar to how the derivative of tangent is positive secant squared. Here in problem 17, we're given that f of x equals g of x divided by sine x. We want to find f prime of pi over 2, given this information about g and g prime. Let's go ahead and find f prime using the quotient rule, and then we'll plug in pi over 2. By the quotient rule, the derivative, f prime, is going to be the derivative of the numerator, g prime, multiplied by the denominator, which is sine x. Then we subtract the derivative of the denominator, which will be cosine x, multiplied by the numerator, which we just know is g of x. Finally, we divide by the denominator, sine squared. Now we just have to plug in the known information. Again, we're evaluating f prime at pi over 2. Now we know that g prime of pi over 2 is 2. We know that sine of pi over 2, hopefully you know your unit circle, that is 1. Cosine of pi over 2 is 0, and g of pi over 2 is root 2. Finally, again, in the denominator, sine of pi over 2 is 1, so sine squared of pi over 2 is 1. Thus, f prime evaluated at pi over 2 is 2, and we found that using the quotient rule and the given information. Problem 18 asks us to find where f of x equals 2x minus 1 over x squared has a horizontal tangent line. So we just need to find the x-coordinate where a horizontal tangent occurs. To do that, we'll use the quotient rule to find f prime, and then set it equal to 0 and solve. By the quotient rule, the derivative, f prime, will be the derivative of the numerator, which is 2, multiplied by the denominator, which is x squared. Then subtract the derivative of the denominator, which is 2x, and multiply by the numerator, which is 2x minus 1. Finally, divide by the denominator squared. X squared squared is x to the 4. So this is f prime. To answer the question, we need to set this equal to 0 and then solve the equation. If this equals 0, we need the numerator to equal 0. So we need 2x squared minus 4x squared plus 2x to equal 0. I just distributed the minus 2x through the parentheses. Then the negative 4x plus 2x is negative 2x. So we have 2x squared minus 2x equals 0. Factoring out a 2x, we have that 2x multiplied by x minus 1 equals 0. And thus, there are two solutions to this equation. X equals 0 and x equals 1. That's just applying the zero product property. However, the solution x equals 0 is not relevant for us because this function is not defined at x equals 0, so it doesn't actually have a horizontal tangent there. The derivative itself, of course, is also not defined when x equals 0. So the only location of a horizontal tangent on the graph of this function is at x equals 1. And if you plug 1 into the function to find the y-coordinate as well, we find that a horizontal tangent occurs at the point 1 with a y-coordinate of 1 as well. The point 1, 1. In problem 19, we want to find the derivative of 3 times 1 minus sine x divided by 2 cosine x. Again, we'll use the quotient rule, which begins with f prime g, the derivative of the numerator, which in this case is going to be negative 3 cosine x, and multiply by the denominator, which is 2 cosine x. We got the derivative of the numerator because the derivative of 1 is 0, the derivative of negative sine x is negative cosine x, and the coefficient just stays out front as a factor of 3. Then we must subtract g prime f. That's the derivative of the denominator multiplied by the numerator. The denominator is 2 cosine x, and so its derivative is negative 2 sine x. We then have to multiply this by the numerator, which of course is 3 multiplied by 1 minus sine x. Finally, we divide by the denominator squared, which will give us 4 from squaring the 2, multiplied by cosine squared x, from squaring the cosine, of course. Here's what we get once we multiply the coefficients together. We could do more simplification here in the numerator. There's a Pythagorean identity we could apply. I'm not going to go through that though. Let's move on to the final problem, problem 20. This is a word problem, but it's not too difficult. A population of 200 bacteria is introduced into a culture and grows in number according to the equation P of t equals 200 times 1 plus 3t over 40 plus t squared, where t is measured in hours. We want to find the rate, that means derivative, at which the population, P of t, is growing when t equals 3. So simply, this is asking us to find p prime of 3. We need to take the derivative of this function and then evaluate it at t equals 3. You can see at t equals 0, this is equal to 200, which is the original population. But of course, the population is growing, and to find the rate at which that is happening, we need to use the quotient rule to take the derivative. The coefficient of 200, we can just leave in front this whole time. So let's first find p prime of t, and then we'll plug in 3 to get the answer to our question. Here is the 200 that we're just going to leave in front, and then we have to take the derivative of what's in the parentheses. The derivative of 1 is 0. That just leaves us to take the derivative of 3t over 40 plus t squared, which we can do easily using the quotient rule. We begin with the derivative of the numerator. That's the derivative of 3t. And that's just 3. We then have to multiply this by the denominator, which is 40 plus t squared. We then subtract the derivative of the denominator, which is going to be 2t, multiplied by the numerator, which is 3t. Finally, divide by the denominator squared. That's 40 plus t squared squared. And this is the derivative of the population function. Now we just plug in 3 for t and evaluate to find our answer. So based on the derivative we just found, p prime of 3 equals 3 multiplied by 40 plus 9, so 49, minus 6 times 3 times 3, so that's 6 times 9, which is 54. And all of this is divided by 40 plus 9 squared, so 49 squared. Again, we just plugged 3 into all values of t. Doing the math, this is 93 over 2,401, or about 0.039 bacteria an hour. That is the rate of increase of the population 3 hours into this process. And here are 5 more quotient rule problems you can try on your own. If you find my videos helpful, please consider becoming a member to support Wrath of Math and get access to an additional 10 problems, including the 5 you can see here, as well as the 5 I've covered, and of course, the full solutions in an additional video. So channel members, I'll see you there for 10 more quotient rule problems. And here is one last scroll through the problems and solutions we did. I hope you found this video helpful. Please let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Thank you very much for watching.
Integrity, I'm a secular and aesthetic from my own effigy. I didn't try just to be regular.